Hey everybody, we are just going to give everyone a few minutes to filter in, let everybody get set before we go ahead and start the presentation. So I'm going to go on mute for about 20 seconds, and as the attendee room fills up, we'll get ready to launch. So just hang tight. Okay, so we're going to go ahead and get started. Good afternoon, everyone, and welcome to today's webinar, Monitoring Kubernetes Across Data Center and Cloud. Before we get started, I want to quickly review the pace of the webinar and what you can expect from our presenters today. First, please know that all attendee lines are muted to control for any background noise. If you have a question at any time, feel free to send it through the question window located in the control panel. We will leave 15 to 20 minutes at the end of the webinar for a Q&A session with the presenters at the end of the presentation. To give you an idea of how the webinar will flow today, we will treat it more like a conversation between presenters. There will be an open dialogue between them and the presenters throughout the webinar, and there will also be a live demo. So again, if you have questions, please feel free to send them through and we'll address them at the end of the presentation in Q&A. For this presentation in particular, the presenters will be sharing their screens, and so if you get thrown back into the holding window, you did not drop out. It's just because a different presenter is taking over the screen share, so just be patient with us. Finally, the webinar will be recorded and made available to you via email and on demand within the next few days. With that in mind, I'd like to introduce our panel of presenters, Alon, Aparna, and Alex. So Alon is the Director of Technical Community at Datadog. Prior to joining Datadog, Alon spent a number of years leading infrastructure and reliability engineering teams at organizations such as Uyala and Edmunds.com. In addition to his work at Datadog, he's active in the open source and DevOps communities, where he is a co-organizer of events such as Scale, Texas Linux Fest, DevOps Day LA, and DevOps Days Silicon Valley. Aparna leads the product management team at Google for Kubernetes. She works in enterprise software. She's worked in enterprise software for 15 plus. She holds a PhD in engineering from Stanford. And finally, Alex is a customer-facing engineer at CoreOS. He thrives helping customers understand, evaluate, and build solutions based on CoreOS technologies. Alex previously worked in roles such as infrastructure and operations, virtualization, and cloud technologies. And with that, I will let Aparna take it away.
Great, thank you. Welcome, everyone. So I'd like to introduce the Kubernetes project and start with that. About 2 years ago, Google open sourced Kubernetes. This is software that was based on the Borg system that is used internally at Google to run all of our applications. Kubernetes was meant for the external world, and it has, over the 2 years that it's been out there, become one of the top GitHub projects. It is a production-grade container scheduling and management solution, and it is very much community-led and owned by the Cloud Native Computing Foundation. Today it has over 950 contributors and over 35,000 commits. The key premise and the key value that Kubernetes offers is that it runs anywhere. It is a multi-cloud platform for container orchestration, and that means that customers and users use Kubernetes on-premise, on bare metal, using OpenStack and otherwise, and also in various clouds. Google Cloud Platform is one of those clouds. It is also widely used on AWS and in Azure. So this project has received broad industry adoption, and you can see some of the logos of companies that are using Kubernetes, both in the cloud and in-house. Also, there's been quite a few companies that offer commercial enterprise support for Kubernetes. CoreOS is one of those companies, and we'll have Alex Saul today talking about Tectonic, which is one of the leading enterprise-supported commercial offerings of Kubernetes. There's also OpenShift by Red Hat, and recently, earlier this year, Huawei announced a cloud-based offering that they are launching based on Kubernetes. Additionally, there are many other companies such as Mirantis that provide enterprise support. So just a little bit about Kubernetes and what it actually does. I think folks are probably familiar with containers and the benefits of containers, primary amongst which are, of course, portability from cloud to cloud, but also, of course, faster deployment and scale-up. So containers spin up and spin down in less than a second and can be scaled up very quickly. And then lastly, perhaps most importantly, is resource efficiency. But what happens when you have a sea or an ocean of containers, much like in the past people had VM sprawl? There needs to be something to manage the containers. And there are a number of functions involved with that. And that is really where Kubernetes comes in and has become a leading container orchestrator. The types of functions that Kubernetes provides are obviously scheduling, which is which nodes, whether bare metal or cloud nodes, where should these containers run. Also lifecycle and health, making sure the containers are running even as they're scheduled at the most appropriate place. Scaling your application, and therefore scaling the underlying containers that are running the application based on a variety of things. It could be metrics that are gained from the health of the application, or it could be the underlying infrastructure like the CPU and memory utilization. Obviously, for things like automatic scaling, monitoring is extremely important, and that's one of the things we're going to be talking about today. This slide has a number of the other functions that Kubernetes provides, naming and discovery, so how do you find out where your application is and which containers and which nodes it maps to. Load balancing, so that it's served, your application is served out of the most appropriate location, appropriate resources that have capacity. And then obviously storage and networking and all of the pieces that go into providing the infrastructure. Again, today we'll be focusing on logging and monitoring. So we mentioned that Kubernetes offers a lot of choice, and that's important for hybrid cloud deployments. And so there are a number of decisions that a user needs to make when they're setting up Kubernetes. Those decisions include choosing a cloud provider, choosing what the operating system is on the nodes, a variety of choices there, and then actually provisioning the machines, installing your runtime, configuring the networking and starting the services, and so on. That can be a challenge, and for users that are just getting started and or users that are looking for simplicity and want to get started quickly, Google offers GKE, which is also called Google Container Engine, and it's our hosted, internally managed version of Kubernetes. It uses the upstream code, so directly what is available in GitHub is exactly what we deploy on Google Cloud Platform, and it rolls out within a couple of business days from the latest open source release, so it is always current. It's also a great mechanism for us to find out what features are popular with users and what, if any, issues exist with the system and contribute those back into the open source community as quickly, usually immediately. And then it allows us to offer all sorts of features, obviously things that are stable in Kubernetes, but also as of the 1.4 release, we offer an alpha channel or alpha clusters so users can try out the newest, latest, and greatest features that are available on GitHub. So I'm going to talk a little bit about how monitoring works on Google Container Engine, but first, just a little bit of the customer and user stories that are around GKE. You might have heard that GKE is where Pokemon Go, the global game, was launched and hosted. So they're one of our customers. Also Philips Hue, which is an IoT use case, and then many others that are listed here. And some of the feedback we've received on Google Container Engine is that it is high performing and very flexible and allows customers to get started very quickly, but also that it is very easy to use. And so here's a screenshot, and I'll show at the end of this just how easy it is to create a cluster, get a service started, monitor it, and use it. So how monitoring works in Google Container Engine. Essentially, in Google, when you start up a cluster in Google Container Engine, you can choose the number of nodes that you want, and your master is automatically provisioned and managed by Google. And all of the other things that are needed to actually monitor the cluster are pre-installed. So what I'm going to be talking about today is not something that the user needs to set up, but just a behind-the-scenes look of what happens when you do set up a cluster. So there's a component called CAdvisor that runs inside Kubelet, which is an agent that runs in every node. A node here in Google Cloud would be a VM, a compute engine VM. And this CAdvisor, it gathers statistics from all of the containers that are running on the node. And then we have an add-on component called Heapster, which is shown in red here. And again, this is all automatically installed on the cluster. Heapster runs as a pod in the cluster, just any other pod in one of your nodes. It doesn't have any special access, and it aggregates the statistics from CAdvisor from each of the nodes. And so Heapster aggregates all of the statistics from all of the containers that are running in your cluster. And these statistics are then aggregated and pulled up and then stored in a storage backend. And from there, they're available for things like automatic repair of the master, as well as for things like scaling of the master. And also they are available for end use, and so for viewing and action by the users themselves. So the primary job, of course, for us in collecting these metrics is to ensure that the Kubernetes master is always available and it is automatically resized as the number of nodes grows. And this is because Google Container is a managed offering. So we make sure that we repair any sort of event, and we obviously have alerting, and we have an SRE team that makes sure that everything is running properly. But also, as I mentioned, the metrics are collected for end users to view and to do with them as they please. The type of metrics that are collected are CPU usage, limits and utilization ratio, and similar metrics for the memory and disk. Lastly, as we mentioned, Kubernetes is a very open type of platform, and so even on Google Container Engine, users are free to plug in any type of different monitoring that they like, and many of our users do so, and they do so either as an alternative to Google Cloud Monitoring or in addition to Google Cloud Monitoring. And so these are some of the other types of programs that you can run in order to aggregate metrics and view metrics that are particularly application specific. Datadog is one of the more prominent ones, and we'll be hearing much more from them. In this case, Datadog will be running as a daemon set on the Google Kubernetes cluster, and they will also be using kube state metrics. A little bit more about kube state metrics. So this is an open source program that is available, and it basically can be deployed alongside your other applications as an additional service, and it generates metrics about the state of the logical objects, so additional metrics about the node capacity and the node status, and you can read more about it on GitHub. It exposes these metrics via an HTTP API or via the Prometheus format. So that is an overview of cloud monitoring, Kubernetes, and GKE. I'm just briefly going to show you the setup for how you would just start a container engine, since it's very, very straightforward. So this, I'm in Google Cloud Console, and in the Google Cloud Console, you would select Container Engine, and to create a cluster, you just click Create Cluster. There's a number of simple options like the zone, the type of machine, the type of image, the number of zones that you want, and you can turn on logging and monitoring. Stackdriver logging is turned on by default. There are a number of additional kind of advanced options if you want additional zones or you want to turn on auto scaling. And then you just click Create, and it starts to create a new cluster. For the purposes of our demo today, we've created a cluster already, so you can go into the cluster. There's a endpoint available. But also, what's handy is this Google Cloud Console, so you get a shell environment that has kubectl and gcloud already installed, and so that can be handy for getting things started in this cluster. To connect to the cluster, there's some directions that you can use right from the UI. And also, you can set up, you can start a service like an Nginx service, which is what we'll be using here, using kubectl create, and then you can create the service from the YAML. I'm just going to quickly show you the YAML. And so this is a service that we'll be using in this demo. And so now we're going to have a demo by Datadog where they talk about how to monitor a deployment that is hybrid between both Google Cloud, and so there'll be an Nginx service running in Google Cloud, and then one that's on-premise with Tectonic. Alex, over to you.
Thank you, Aparna. All right. Hoping everybody can see my screen now. Hi, everybody. My name is Alex Sol, and I'm part of the CoreOS team. Here at CoreOS, we've been contributing heavily to the Kubernetes project since its inception about 1.5 years ago, and we're one of the key contributors to the project. Our main focus at CoreOS is really around the enterprise use cases for Kubernetes, namely around the areas of security, ease of operations, integration into the various different enterprise services, manageability, lifecycle management capabilities, and running Kubernetes on various cloud provider and on-premise environments. So with that said, we do have a enterprise Kubernetes distribution called Tectonic, which I'll be covering briefly. So as Aparna mentioned, users and operators do have a lot of choices on components and bits and pieces to put together to form a Kubernetes cluster. Tectonic is opinionated in the sense that it's built on the technologies that Tectonic team does support end-to-end. So we do use a good chunk of the technologies that either the CoreOS team built or contributed heavily into. So with that said, for the next half a year or so, our main focus is really Tectonic team is really around the cluster installers. So we do have UI-driven installation procedures and installers for AWS and bare metal environments. And we also are working heavily on management software to update, backup, roll back, scale up, and scale down the Tectonic and Kubernetes clusters, and also being able to provide a nice user interface that is specific to Tectonic technologies and surfaces some of those management functionalities, such as cluster information, compute usage, role-based access control, along with being able to ship with some of the components to ease off those management challenges that the enterprise customers may see. With that said, Kubernetes do provide the container orchestration, scalability, high availability, and a lot of the service discovery and load balancing features upstream. And some of the features, such as alerting and logging and security interfaces, registry integration, those are all typically left up to the operators and users to choose the technologies that they would like. So here at Tectonic team at CoreOS, we're really providing some out-of-the-box capabilities around those to make Kubernetes easier to be adopted at the enterprises. So one of the flagship projects we're working at CoreOS is Bootkube, which is part of the Kubernetes incumbitors project in GitHub, and Bootkube will allow some of the lifecycle capabilities that I've been talking about. So customers do love CoreOS Linux because of the ease of updates for the operating system it does to things such as security vulnerabilities. So Bootkube project is intended to bring similar painless update capabilities and structures into the Kubernetes project. And at CoreOS, we're very centric around the security aspects. So we've been doing a lot of work on both upstream project and within Tectonic as well to introduce and improve the security posture of Kubernetes. So we did open source vulnerability scanning component called Claire, which can scan the actual container images for known vulnerabilities based on the distributions that they may have, and provide reports and alerts to the end users as to what potential vulnerabilities may be inside their containers. For platforms that support things such as disk at rest encryption and KMS type of capabilities, we do have integration with those. And a lot of the enterprise customers do like to have the integration with their on-premise or existing identity providers such as LDAP or OAuth providers for integration into the Kubernetes, along with role-based access capabilities such as multiple users and departments can utilize the same Kubernetes cluster, so that they get the pool of resources that can be shared among the departments, but still have limitations as to which users can perform what type of functionalities. So with that said, I'll take a quick overview of the Tectonic console. So within the Tectonic console, you can see that we, within the homepage, we display some useful cluster status information, and we do have a selection for different namespaces. So along with that, we also expose different objects that exist in the Kubernetes cluster, along with some administration capabilities such as users that can be created and deleted, role-based access control information such as nodes. In order to demonstrate multi-cloud capabilities of Kubernetes, we've actually provisioned this cluster on top of Packet. Packet is actually a bare metal cloud provider. So just to show what these cluster is running on is I have these two nodes that has been provisioned in the New Jersey data center of Packet, and these are bare metal machines. So essentially they've been brought up to an automated system, and an operating system has been provisioned onto them, but this is not a multi-tenanted environment. So this is very much similar to an enterprise data center where there's a physical machine that's not shared by any other tenant, or not shared by not utilizing any virtualization technologies. So this cluster itself is running on Intel Atom processors with 8 gigs of RAM and certain specs. So it's a tiny but mighty machine that can be used to provision this machine. We do expose the various objects within Kubernetes. So as an example, we did deploy prior to this demo, we did deploy an Nginx application. As you can see, we do have this similar to what Aparna showed in her GKE cluster. We've provisioned essentially a manifest. As you can see from the UI, we did have 2 replicas for this to facilitate this workload. And you can actually, through the UI, you can scale up and scale down this workload and modify the labels, make changes to it. So if you'd like to roll over to a different tag or a different version of the Nginx or any type of workload, you can do so from the UI and update the desired state. In order to expose this application, we do use Kubernetes service abstraction. So we've also created a service for the Nginx application, and this is exported to the high port 31036. And if I were to actually refresh this page and access this cluster through the high port, you can actually see me hitting this particular service. And as I mentioned before, I can make changes to the scale of the application. So I can modify this count from 2 to say 5, and Kubernetes goes out and spreads the workload, and you can now see that I actually have 5 replicas of this application running. So with that said, I'll pass the presenting status back to Ilan. So Thank you.
Thanks, Alex. So we will just. So as Alex and Aparna were mentioning earlier, Datadog is a monitoring platform that focuses. We're a SaaS-based monitoring solution focused on infrastructure and application monitoring. We tend to fit in well with modern environments, things like cloud containers and microservices, which is, of course, why we're here to talk about Kubernetes. We like to focus on areas where our dynamic configuration abilities can really excel. At this point, we're processing about 1 trillion metrics per day, data points per day from our various customers. That's metrics and events, and we tend to focus on algorithmic alerting and dashboarding. So recent things like anomaly detection and outlier detection coming out to help you have tooling that's as monitoring tooling that's as dynamic as the environments that you're that you are monitoring. So we like to say that collecting data is cheap when you have it, but it's quite expensive to try to get it when you need it. We've made some marvelous changes in our progress in the world of storage and cloud computing. We can store tens of terabytes a day per month in places like Google Cloud Storage for just a few $100s. Unfortunately, we have not made the same progress in the world of time travel, and so Marty and Doc Brown haven't given us the hoverboards or the DeLorean just yet, and we can't go back when an incident has happened and try to collect data after the fact. So it's really important that we try to get that data now while we have it, and store that for as long as possible. So Datadog will offer you the ability to store at second level granularity for a full 13 months to give you that year-over-year seasonality and as you're trying to do your trending, so you can come back and make business decisions or identify the root cause of incidents over time. So when we say monitor everything, we do mean monitor everything. Yes, we're focused on Kubernetes and containers here, but in general, we'll connect with everything from operating systems to cloud providers to your applications and data stores and caches and queues and pretty much everything else in between. You'll even notice there's some logos of other monitoring systems here. Our goal is to bring everything into a single pane of glass so that you can reason about your environment. Again, storing that data in a as granular fashion as possible, keeping it for about a year so that you can do that year-over-year trending, and letting you correlate the data between all of these different pieces. So how does Datadog fit into the Kubernetes and container space? So one of the way that we collect data from various applications that we integrate with, as well as with Kubernetes and Docker, is with an open source agent written in Python. We deploy this alongside on your VMs or as a Docker container deployed as a daemon set within your Kubernetes cluster. The way we collect metrics from Kubernetes itself is we'll talk to the container engine itself. In this case, Docker. We'll work with some of the services like Heapster that Aparna was showing us earlier, as well as kubestate metrics, which provides a little bit more. Provides a little bit more application-focused and stateful metrics about your environment that Heapster does not offer out of the box. These are great for getting the sense of your cluster health, things like how many containers are deployed versus how many containers you are targeting, things as such. We can also integrate with cloud providers, as we mentioned earlier. So in this case, we're working with GKE, so we'll pull in data from the Google monitoring APIs. For your own applications, of course, you might have custom metrics that you want to collect. Maybe your maybe how long it's taking your customers to complete a given action, or how successful a given transaction is being. For that, we support things like StatsD for emitting metrics directly to us via a push-based model. All of these metrics that you send to Datadog get automatically tagged by pod, by label, by replication controller, and all the other different aspects within your Kubernetes cluster, as well as from Docker. And so this is quite helpful as you're trying to slice and dice your metrics, and we'll dive more into that in a little bit. So the reason we're all sort of excited about this containerized world, as Aparna was touching on earlier, is that it really simplifies our deployment models, right? We can deploy our applications, scale them up easily and efficiently. work with great partners like Tectonic and GKE to make sure that our infrastructure is easy to integrate with. But along with all of this, with all of this improvement to our deployment style, the question is also what are the trade-offs? What are some of the is there any complexity that we're gaining as we give up all of the as we get all the new shininess and smoothness of deploying in the Kubernetes world? And so, to think about that, let's maybe define what operational complexity is and how that would apply here. So we like to define complexity as number of things that you're measuring or monitoring or tracking, and the velocity at which they are changing. So if we try to look at how much we're measuring, again, this is from averages across cloud providers, but we tend to find that a given instance is returning about 10 metrics from the cloud provider itself, at least 10 key metrics. Your operating systems, again, in the case of Linux, maybe about 100 metrics that you might be interested in, and then maybe another 50 metrics per your application. But again, we're not doing single tenant environments anymore. So we do have containers running concurrently, and in our studies, we're finding that hosts are running about 5 containers at a time. This number is trending up, and especially in orchestrated environments like Kubernetes, the number may even be higher. So this is, this definitely increases the number of things that we're trying to monitor as well. If we look at things like, if we look at just do some of the math very quickly here, we take what used to be 100 instances now becomes 500 containers. We go from 160 metrics to maybe 800 metrics per host. Again, assuming 5 containers per host. At 100 instances, that ends up adding to about 80,000 metrics. That's quite high, especially if you're talking about collecting these again at second level granularity. Additional things that we have to monitor, of course, are we're no longer just monitoring the host itself and the application, but we're also looking at the higher levels of our environment. So we're looking at things like the orchestration itself, our cloud providers, and other layers here. This further adds to the number of things we have to track, and again, where complexity continues to increase. So it's you'd be forgiven if you just kind of looked at this and thought, well, that's a lot of metrics. I'm a little overloaded here. What do I do and how do I process this? So we've clearly not checked off the number of things to measure box. If we start to look at velocity of change, though, and wonder how quickly things are moving, in our recent Docker study and container adoption study, one of the things that we found is that the average lifetime of a VM is down to about 15 days at this point. Whereas containers, on the other hand, are about 2.5 days. And this is even lower, again, in orchestrated environments where things may be changing and moving around by your orchestrator outside of your control. So the amount of time that things are moving around, the number of things that are, the velocity of that change is actually quite high. So we've now checked off both the boxes for operational complexity, but there's great tools that we can use here to sort of help simplify this. This is where tools like Tectonic and GKE come in, but also with Datadog again to monitor it. So what are some of the questions that we might have about this new containerized infrastructure? Well, as we're trying to monitor things, we want to know where they're running. Again, we've kind of talked about how Kubernetes is moving these around for you, so that you always have the guaranteed capacity that you're looking to run in your environment. You might want to know what the overall capacity is of your cluster, so that you can determine if your developers or your teammates can deploy new versions of the applications or a new application. As you're trying to configure your monitoring systems, you might wonder, well, what ports are these things running on? As you want to get at, Alex deployed Nginx earlier, maybe we want to get statistics from those Nginx apps. Things like throughput, et cetera. And then we're going to want to break those down by data centers, by tags, by application versions, and try to figure out where we're at. So as we're trying to think about this, it's important that we realize that with Kubernetes moving things around us, we have to sort of shift the way we're thinking about things and not worry about the host as much anymore. Some of those questions about, for example, where things are running, not as critical at this point as, whether or not your service is up. This is the image here that you're looking at here is the Ptolemaic model of the solar system, and much like the world was quite figuring out where things in the solar system was quite complex as we tried to reason about them with the Earth at their center. It's a similar idea as you try to think about whether or not your services are up based on individual hosts or containers. Again, what you really care about is the service. So if we flip this around, much like the world got simpler when we thought about the solar system having the sun at its center, and it became much easier to think about where things were. We can do the same with our applications and our services. And rather than thinking about those individual infrastructure units, we start to think about the service and collect metrics about them as a whole. This makes it much easier to reason about whether or not our services are online and whether or not our customers are happy. So what does that mean? Well, as we're collecting our data points, as we're collecting data about our environments, we can sort of start to think about this in the same context as the 5 whys we might have learned about in a journalism class, for example. The metric name is the what. These are the things that we're trying to measure. So in this case, we're looking at network usage. Later on, we'll look at Nginx and Kubernetes metrics. The how much is the is for here. Again, in this case, the number of bytes received. The when is your timestamp, and the tags are where. Now, again, the tags are these are fantastic in the world of dynamic infrastructure with things like Kubernetes and cloud providers and containers. They're all offering tags and metadata about themselves as we interact with them. Every one of these pieces of our infrastructure, all the way up and down the stack, allow us the ability to set metadata about our environment. So what does that mean in the Kubernetes world? Well, as you're labeling your services, you've got your backends, whether it be backends versus front ends, versions of your application, staging versus production, etc. It makes it very easy to slice and dice your metrics across all of these different axes. At the same time, Kubernetes will use these labels for routing between your application tiers. So we can then take these tags and these metrics and use them to ask more intelligent questions about our environment, about our environments and our applications. So, for example, rather than asking, if a given instance of Nginx is online, again, that's the application we were deploying earlier, we can instead ask, what's the throughput of the cluster as a whole, and use the tags that we were collecting earlier from Kubernetes and Docker as predicates. So we might say things like, show me the throughput of all my Nginx applications by version. Again, version also being a tag. Anything underlined and bolded here would be a tag. Alert me when my pods is behaving differently using some of that anomaly detection magic we talked about earlier. We can also talk about things like show me error rates or success rates across my data centers. Again, 500s versus 200s. So how do we get at all that data, right? We've talked a lot about getting at Kubernetes metrics and about getting at Docker metrics, but we talked earlier about how these containers are moving around and our applications may not always be on the same port or even on the same hosts. Generally, when we've set up monitoring systems in the past, what we've done is point them at a single place, set a particular threshold that we're concerned about or excited about, and kind of let those results lay and notify us when things change. In the world of Kubernetes and containers, as these things are moving around, it's a little bit more of a challenge because normal is not, may change from minute to minute and definitely from day to day. So many modern monitoring systems are offering you a way to auto-discover the applications that are running via things like service discovery or other dynamic configuration. Again, remember that because these things are moving around so quickly, your standard ways of handling configuration management, be it Chef, Puppet, or Ansible, which may have 10, 15, 30-minute converge times based on however you might configure them, will not necessarily move as fast as your auto-scaling or your pod scheduling. So here what we've done is we've enabled the Datadog agent to pull configuration snippets from either from templated out configurations on your local file system or from config backends like etcd or console. We can similarly configure and determine what to monitor on a given pod or container using pod annotations. We're using the service discovery feature. So what we do is we'll watch the Docker event stream, see as these containers are coming up and down. We'll pull up metadata from Kubernetes, again, tags, labels, etc. Use those all to define what you should be monitoring on a given host. So that's sort of, as a quick visualization, as these Nginx instances are moving around again, Alex earlier had, scheduled a scale up and scale down of our Nginx cluster. You can see the Datadog agent is picking up those changes and points to the new location. And so with that, we'll switch over to a quick demo of the Datadog platform and kind of show you how we've done this with the clusters that Alex and Aparna have spun up, and then show you some of the magic of monitoring here in Kubernetes-based environments. So again, as you recall, we have two different Kubernetes clusters here. One is the one that was spun up by Aparna, and the next one here, again, they look fairly identical, is the one spun up by Alex over on the Tectonic cluster. If we go ahead and pull these up in Datadog, this view here that we have is something that we call the host map. This shows all of the infrastructure that you have set up in your account. You notice we have about 5 nodes here. Each one of these hexagons represents a node, and we can see what's running on them. We can kind of zoom in and see that they've got, these guys have Kubernetes and Docker and Nginx, etc. I can then use a lot of those tags and metadata that we talked about earlier to slice and dice the environment. So in this particular case, for example, I might want to see how things are split between that packet environment and the Google Container Engine environment. Using that tag, I was very quickly able to slice these on the cloud provider access and see that I have 3 nodes running in Google and 2 in Packet. Again, both running, both of these systems are running Kubernetes, and we're pulling in metrics from kubestate metrics and Nginx. So what does that setup look like? Well, in the case of Kubernetes here, again, we have we would have to deploy Datadog here. To get that, we would just grab a daemon set configuration from the Datadog UI and launch that with kube control. Just one quick command, then we had this running on every node in both sets of clusters. That in turn starts to pull together dashboards like this. So for example, here on the right, you'll notice in our Kubernetes events about 18 minutes ago, Alex had spun up and down some copies of my Nginx example app. We can sort of see that they were starting. If we go back earlier in time, we may see things like other applications that were deployed. We can see things that, deployments that have succeeded or failed, etc. Again, we're showing things. We're able to show you things like most intensive CPU pods. Again, in this case, we're running Nginx, so you'll see that these are the most resource-intensive pods at the moment, just given the traffic headed toward them. We can show things like memory and metrics, etc., across all of your different services to show you your Kubernetes cluster health. Again, using those tags earlier, it's very easy to take templatized dashboards and switch between, focus only on Google, or focus only on Packet, or some other provider that we might be working with. We can do similar things for replication controller.
So sorry to interrupt you, but it looks like you might not be sharing your screen anymore, and so we have a couple people that definitely want to see what you're doing, but we happen to be in the waiting room. So if you could just check to see what's going on there, that would be great.
Yeah, I'm looking into that right now. I'm sorry. It looks like that suddenly stopped. So I guess let me go. I'm not sure where that cut out. Do you know, Rachel, what was the last thing folks
I would start from probably just about a minute ago. So if you want to just backtrack, I would say maybe about a minute in what you were saying. That would be great.
Sure. So again, we were showing the host map earlier. The idea here is that each of these hexagons represents a node in your infrastructure. In this case, we're showing nodes from the five nodes that we have deployed across Packet and Google. I can use the metadata that we've pulled in earlier around things like cloud provider or application, and very quickly slice and dice the environment in that way. I can zoom in on these particular hosts, see not only where they're running, but what's running on them. So in this case, we can see that Kubernetes, we're pulling stats from Kubernetes, Nginx, NTP, etc., and similarly over here on the Packet side. As I mentioned, the Kubernetes setup involves just a quick
Alon, sorry, it's me. One more thing. It looks like now we're on a screen that says pause, so let's try it out.
That's great.
Well, the good thing is everybody is very excited about what's going on.
Yes,
so
I'm sorry about this, folks. Let's see what's going on here.
Okay, let's see.
How about now?
You can see the presentation.
Great.
And now
sorry about that, folks. Let's try it. I think we got through the host map portion.
I have a lot
so
of yays and yes, and it's back, so I think you're good now.
Okay, I think I'm gonna. So we've done the host map piece a few times now. I think we got through that the first time without issues. But again, we're looking at. Each of these hexagons represents a given host in our environment. We've used the cloud provider tag here to slice and dice across them. We can similarly use other aspects. So, for example, if we were wanted to just focus on the Google side, we might be able to show just the different zones our individual instances we're running on, et cetera. And so the tags are quite helpful here as we're trying to figure out how our environments are performing. The Kubernetes setup is quite simple. It's just you grab a quick daemon set configuration here, and you run that with pass that into your kube control command or into the Tectonic or GK UIs, and you can very quickly deploy Datadog across all of your instances to collect metrics automatically from those integrations we talked about earlier. Here we're looking at a default Kubernetes dashboard. On the right here we have a list of events coming from Docker and Kubernetes. You'll notice here about now 22 minutes ago, Alex had scaled up and down some of the Nginx pods that we have running in the packet cluster. You can see things like the packet tag, the namespace that we're deployed in, etc. We'll break down resource metrics and utilization across the cluster of things like CPU and memory, and we can do that by pod or by container or by application. Again, using the tagging metadata, the tags and metadata that we had earlier, we can very easily slice this across the different data centers that we're looking at. So I've just switched back from looking just at packet to looking at across both clusters. I can similarly go focus on just Google and see the containers that are running over there. We can do similar things over here on the Nginx side. Remember, we had been deploying Nginx earlier, and we were sending traffic that way. And so, out of the box, we'll provide dashboards for a lot of the open source applications that you might be interacting with. You can easily customize these for your own needs. But in this case, again, we're using a fairly standard Nginx configuration, pulling out Nginx statistics. And similarly, using those tags, we can ask interesting questions about an environment or filter down to particular environments that we might be interested using our templatized dashboards. So, in this case, I flipped to just Google, but I could go to Packet or what have you, or scope down to any other point. Of course, we can't spend all of our time looking at dashboards all day. So we will often want to create alerts on maybe something that might be problematic. So in this case, here I've gone ahead and just sort of predefined and very quickly here metrics that I might want to collect from Nginx. So if we look at, for example, requests per second coming into my Nginx cluster, I've now quickly graphed these. Again, we store these at full granularity for 13 months, so you can very easily switch between the different views and get look further back to see whether or not you're alerting on a timeline that makes sense for you. Is that that seems to have stopped the screen again. I'm sorry. So anyways, that's we can use those to very quickly group again by the same metadata that we were using earlier. So maybe one alert on individually on each given cloud provider or on a given pod or other group by any other tag or metadata that we might have collected. And so that's I think we can probably shift over into the Q&A. I'm sorry for the some of the technical challenges here as we were running through the demo, but looking forward to chatting with you all about how you're monitoring containers and Kubernetes.
Absolutely. Thanks so much, Alon. So I'm going to give everybody just about 20 to 30 seconds to send through any additional questions that you may have, and then we will get started on the Q&A section. So if there are any questions that you have for any of our presenters, Aparna, Alon, or Alex, just send them through now, and that would be great. And Alon, if you could put that back up onto the Q&A screen just as a placeholder, that would be awesome.
Yeah, I'm sorry about that. I'm not sure why this did
No, no problem, no problem. Okay, so we'll go ahead. We do have some questions that are coming through. Let's see. For Alon, are the stats container per host or pods per host? And is the service mostly based on environments? Is it mostly service-based environments?
So we're collecting those metrics at all the different levels that were mentioned, so because of the magic of tagging, it's very easy to aggregate at the different levels. So you might be looking at an individual container, looking at the pod looking at individual pod, looking at a replication controller as a service as a whole, and then moving up higher level to things like entire data centers or entire clusters. So you can look at this at all the different levels that we were discussing here. I'm not sure I understood the second part of the questions, but I'm happy to, if they can clarify, I'm happy to dive in a little bit more.
Okay, so in the meantime, there's another question. I have my own system. How can I make sure Datadog can see, quote unquote, our metrics? Do you offer an SDK or API?
Yes, so we have a number of different integrations with open source components, as we showed earlier. So you'll be able to pull in things from all of the standard parts of your stack. There are a couple of different ways to pull metrics from your own applications and your own containers. One is you could write, we have a Python-based plugin model. You can write very short and quick plugins to pull the metrics from your own applications. And pull those into Datadog. Again, using service discovery, we would automatically pick up that those containers had started or stopped and monitor them accordingly. We do this based on fragments from the container name or pod annotations or other configuration bits that you might store either on your file system or in etcd or console. We offer SDKs in a number of different languages if you want to push metrics from your application. You can do this either via statsd or our variation called dogstatsd, which enables tags. This allows you to push metrics out asynchronously to the local agent on each individual Kubernetes node. And the various SDKs will fit in with Kubernetes and Datadog in that they will automatically discover what the location of that statsd endpoint is. And then finally, we have a REST-based API that you can push metrics to as well. But I think most folks are going to either be running those Python plugins.
Great. So then another question, and I guess you guys can decide who answers this, but how would you suggest you autoscale up and down cloud infrastructure running a Kubernetes cluster?
Sure. This is Aparna. I can take that. So there are a couple of ways to autoscale the infrastructure in Kubernetes. One is called horizontal pod autoscaling, and the second one is called cluster autoscaling. And they work they're very complementary to each other. What horizontal pod autoscaling does set, so you can say a max and min for the CPU utilization that you would like. So that is kind of the base metric for the horizontal pod autoscaling. Although in the newest release of Kubernetes, we will also be working to add custom metrics that you can set to for the HPA. Secondly, the cluster autoscaler is so the pods are on a node. The node in the cloud is of course a VM, and so what happens if you turn on cluster autoscaling is that if a pod is unable to be scheduled because your nodes are full and it is for any reason in a pending state for a certain amount of time, then the GKE will automatically add a node. And so cluster autoscaling is you add and remove nodes, and so it scales down as well. If you have a node pending, if you have a pod pending for a certain amount of time, the cluster autoscaler will add nodes, and if you're not using a node, then after a certain amount of time it will remove the node. And it's very careful about how long it takes before it removes the node. It actually waits quite a bit of time just to make sure that, in fact, the node is not in use. So those are the two mechanisms. One is, of course, the pod autoscaler, and the second is the node autoscaler or cluster autoscaler.
Great.
If I may, on bare metal providers as well, with Tectonic, we do support some templating engines that allow you to essentially bootstrap a physical machine and join it to the cluster to scale up the cluster as well. So.
Awesome. And Alex, a question for you. Is Tectonic fully compatible with open source Kubernetes? And how soon after Kubernetes is Tectonic released?
Thank you. So Tectonic is fully compatible with Kubernetes. We do ship Kubernetes as is, and from the upstream code, we don't carry any patches for the most time, and we don't do any forking of the code base. We do simply do repackaging to fit on the actual Tectonic platform, along with doing some QA testing and integration testing along with the integration. So for the release cycle itself, we're typically cut a release of Tectonic a couple weeks after the official Kubernetes release to go through our packaging testing efforts and also do some improvements around our tooling, around the components that we ship with Tectonic as well. In cases of security vulnerabilities, such as there's been some security exposure that's been announced about a week or 10 days ago with Kubernetes that's been patched in the open source project. So in instances of those, we're typically very streamlined, and we were able to get a fix out in I believe about 24 to 48 hours.
Great. And then another one for you, Alex. Does Tectonic support Calico?
I'm sorry, the question was, does Tectonic support
Calico? C-A-L-I-C-O.
Sure. Yeah, so we do have good partnership with the Project Calico team, and we actually started a joint venture with them named Project Canal that integrates some of the Flannel components along with Project Calico components. So we're in good partnership with the Calico team, and we do have Calico Calico for transport as well.
Great. Alon, another one for you. Is the performance impact of Datadog monitoring significant to the instances hosting them? And is there any suggested amount of resources to give Datadog as a default?
So we generally focus quite heavily on making sure that the Datadog agent itself is fairly lightweight. You'll generally be seeing using far less than 1% of the resources on a given system. In terms of the how much in the Kubernetes config plugin calculates the first 200 digits of pi. That might use some CPU. So there's some variability based on what you choose to do with the agent. But by default, all of our integrations are quite lightweight. So the idea is you should be able to run these everywhere and collect all the metrics that you're looking for without impacting your application.
Great. Let me see if we have. So I'm getting a lot of questions about what Datadog integrates with, and I would recommend we have an integrations page. And so if you go onto our website, correct me if I'm wrong, but I believe it's datadoghq.com/integrations. You can check out all of the different integrations that we have available. Is that correct?
That's correct. There's about close to 200 integrations at this point for a lot of the open source projects, a lot of open source and commercial offerings out there. I kind of just scrolled really quick here through some of the integrations available on our integrations page, and if you want to check out the website or reach out to us, afterwards, I'm happy to chat more about individual applications that you might want to monitor.
That's great. Okay. Are there any? Let me see if there are any final questions. Just give me one moment. Okay, I think that we are all set for today. I'm about to send through a couple links around Kubernetes in case anybody is interested on following up on that auto-scaling question that we had earlier. So if you check your questions box, those links came around now. And since that is the end of our Q&A section, I just want to give a big thank you to all of our presenters, Aparna, Alex, and Alon, for putting together such a great webinar, and to our audience for taking part and being so active and present today. It was really great. Just as a reminder, this webinar was recorded and it will be made available to you via email and on demand within the next few days. So thank you again, everybody, for joining us, and have a great day.